Hey, what is good everybody? Welcome back to the channel. In today's video, we're gonna be basically tackling how to draw our very first triangle, which is the one that you guys are seeing right now. So let's get into the video and let's get to it. So now if you guys are coming back from the previous video, you'll know that we managed to set up our very first renderer and got the screens clearing to black. So therefore, if you take a look at our renderer, you can basically see that it's really not a lot of lines of code. That's just the beauty of metal and working with metal. You really don't have to do a lot to do something amazing. So in today's video, we're gonna get straight to it and start developing our triangle. So what does a triangle consist out of, right? If you don't really know math or geometry, I'll just give you a quick detour on a quick tour on how a triangle basically looks like. So a triangle looks like this, and it essentially has 3 points, right? And these 3 points can be known as vertices, and these vertices can hold certain information, in our case positions of each point, right? Which is basically what we're gonna be passing through to our shaders. And in order for us to pass in those 3 vertices to our shaders, we need to store those vertices somewhere, and the conventional way is to store them in an array, which is something that we're going to do. So if we come down here within our constructor, I want to define some vertices, right? So vertices like this, and then basically we're going to store them in an array, and the data type is going to be a vector float, and that's going to be float 3, since it's going to hold x, y, and z positions. Now since we're working in 2D, we're only going to be making use of x and y, so therefore all you got to do now is essentially just give it the positions of your x and y, and our z is always going to be 0, since we're not making use of any 3D coordinates here just yet. So our very first point, this will be middle, top of the screen, okay? And then the second one will be, let me just copy this, paste it like this one will be on the bottom left, right? So bottom left of the screen, and then this one will be on the bottom right of the screen. All right, so this one will be bottom right of the screen. Now these are the positions of each vertices, and if you take a look, we actually have 3 vertices, just like I told you in the beginning of this video, that a triangle has 3 vertices. Now these vertices, we need to pass them to our shader, right? Now we can't just directly pass them like this, so we need to find a mode of transportation to basically transport these vertices to our shaders. So metal has a data type which is called metal buffer. So at the top, we're gonna define a global variable, and we're gonna call it a vertex buffer, right? And it's gonna be of type metal buffer. Now by definition, a metal buffer is simply just a resource that stores data in a format defined by your app, right? A metal buffer object can only be used with the metal device that created it. And in addition to that, the metal framework doesn't know anything about the contents of a metal buffer. It just knows its size. So you define the format of the data in the buffer and ensure that your app and your shaders know how to read and write that data. For example, you might create a struct in your shader that defines the data you want to store in the buffer and its memory layout. So like I said, our data right now is essentially just an array that holds the data type float 3, which essentially just holds the positions of each vertice. So now we need to take this data and pass it to a metal buffer, and essentially that metal buffer will then send the data to our shaders. All right, simple, isn't it? So how do we populate this vertex buffer that we just defined? So all we gotta do is just say vertex buffer equals to self.metal device, okay, dot make buffer, okay, and then we want the one that says bytes, length, and options. And then the bytes essentially is just the raw data that we're passing in, which in this case is an array of float threes. So essentially we're just gonna say vertices, and then we're gonna need to get the size, which is the length of this data structure. All right, so all you gotta do now is say memory layout vertices, and then dot stride. Did I do something wrong? Memory layout, vector float 3 dot stride. Yeah, there we go. Now this is, if you're coming from C, particularly C, you know when you're gonna get the size, when you want to get the size of a data type, you use something called the size of operator. So this is just the equivalent of that, and then we're just gonna take that size of this data type float 3, and since we have 3 points in an array, we're gonna times that with the vertices dot count, which just equals to 3 since we only have 3 vertices within our array. And then the options here, we're just gonna leave them empty, and then I'm just gonna put an exclamation mark at the end of this line, and then that is it, ladies and gentlemen. We have successfully created our very first meta buffer and essentially populated it with data defined by our app, and now we are ready to take that data and pass it down to the shader. So we're gonna do that using the render encoder. So therefore we can set up here and be like data send data to the shader, and we're gonna do that by simply saying render encoder dot set vertex buffer, and then we're gonna pass in that vertex buffer that we created, right, which we created up here and populated with our vertices. So we're gonna send that all the way to our shader, and we're gonna set the index as 0, and therefore now what's happening is when we go to our shader, right, the renderer is passing in that vertex buffer. So now all we gotta do now is basically capture those vertices in our shader. And how do we get that? So we're gonna get that through passing an argument to this vertex shader, and that's gonna be of type const device, and then the data type here is gonna be float 3, since our vertices are essentially just a float 3 data type. So we're just gonna say float 3, and then we're gonna pass it in as a pointer, so vertices, and then we're gonna give it an attribute tag, which is gonna be the buffer at index 0. So note that here we said the index is 0, and therefore here we also passing in the index 0, meaning that we're indexing this data that is being passed, right? Yeah, so that's what this basically does. Hopefully you understand that better, right? And now what we want to do is we want to output each vertices, and we want to send that data down to the fragment shader. So how do we do that? We essentially just return the float. So inside here, I'm just going to get rid of this, and I'm going to basically pass in our vertices here, and then I'm going to get the vertices, the first vertice that I want to send to my fragment shader. And then since this is a float 4, this returns x, y, and z, and then this one is the last parameter in a float 4. For whatever reason, it has to be a float 4. I'm not sure if it truly has to be a float 4, but usually positions are float 4s for whatever reason. I could be wrong, but yeah, that's essentially what I need to do. And you notice how I put 0 here? This essentially is just basically indexing the first vertice, right? And then when I want to get the second vertex, all I gotta do is just say 1 there, which will then get this one, which is at the bottom left of the screen, and then the last one will be at index 2, and therefore it will be this one, right? Now we could basically do this manually, but it's we don't really have to, because Apple just has a very, very beautiful way of doing it for us, and we just have to use the Apple way of doing things and just define another argument, which is called UI int. We're gonna give it a name called vertex ID, and then the attribute tag will be vertex ID. And what this does is just simply gets all those indices for us and updates them for us on our behalf. So all you gotta do now is just pass in that vertex ID, and essentially just does the same thing. It just iterates through your list of vertices and just passes them out to the fragment shader. All right, so that is essentially it. So how does the fragment shader receive this data type? All you gotta do is create a new argument here, which is a type float4, and then we're gonna call it input, and then we're gonna add an attribute qualifier called stage in, and then essentially now what we're doing here is saying, hey, from the fragment shader, we are going to take in whatever the fragment shader outputs as input, and then we're gonna do some stuff to that input. Right, for now I'm just going to click save and then come back to our renderer. Since we're not done, we've now managed to send data to our shader. Now we need to tell the renderer to basically render that data for us to visually see. So to do that, we basically just say draw primitives, and then we're going to give it of type triangle, and then the vertex here, start here, is going to be 0, and then the vertex count, if you're not sure how much that is, just look at your array. How many vertices do we have? We have 3 vertices, right? So all you gotta pass in here is just the number 3, and ladies and gentlemen, you are done. So if I go back to my content view and just wait for it to update, we have a beautiful triangle. Now we could change the color of this triangle simply by changing the output color. A fragment shader just simply outputs a particular color and basically colors or interpolates through your triangle, colors your triangle. Let me just keep it simple, just basically colors your triangle whatever color you want to color it. So in this case it's white. I want to maybe get a yellow one, so I'm just gonna start populating this back 4 with the appropriate numbers to give me a yellow triangle. So if I save that and come back, boom, we have a yellow triangle. Let's say I wanted a green one, so I'm just gonna do a small change there, and then boom, we have a green triangle like the one we saw in the beginning of this video. And just to get it to look the same way, all we gotta do now is just say frame height 200, or I like 300 a little bit better, and voila, we have a triangle, ladies and gentlemen. It's really that simple with metal. There's really not a lot that you really have to sort of like cram. If you just give yourself time, I believe you'll understand how all of this works. It's really not that complicated. So yeah, ladies and gentlemen, we finally displayed our very first triangle. Now in the next video, we're gonna create a proper data structure for this, because vertices can actually hold more than just one information. It can hold the position, it can hold the color, it can hold the texture. So we're gonna create a much better data structure for that, and then we're gonna turn our triangle into a quad so that we can prepare ourselves to play around with shaders and do some really amazing stuff in the next coming videos. So if you enjoyed this video, do hit the like and subscribe button, and I'll see you guys on the next video. Take care.